Good afternoon. I am Queen. I'll be talking to you about MGRS map. I call it LATMAP because this is not a comprehensive LATMAP class. We're only going to be talking about how to read a map and how to understand MGRS coordinates. We're not going to talk about how to translate those coordinates into real navigation with compasses. One, have time constraint. Number two, the level of navigation that's required at field training. Not that hard. The most difficult part is understanding these coordinates, being able to plot these points, and from there it's pretty common. So MGRS, I'll be talking about what is it, and I'll give you some coordinates to break down to help you understand. We'll look at some real life examples, and if we have time, we'll talk about using a protractor. MGRS stands for Military Grid System. It is a system of which the United States military, as well as our NATO allies, use to mark locations on a map. Compared to traditional longitudes and latitude coordinates, it is simpler and more direct to use in the field. You'll see why later on. That is an example of a MGRS coordinate. Looks like random codes, but once you break it down, it can make more sense. How you want to break it down is by numbers plus one letter, and then two letters together. For the last portion, okay, the last series of numbers determines how accurate your coordinates will be. This, for example, is an 8-digit coordinates. Okay, so count the last section at 8 numbers. Okay. Once you get that number, you want to split them in half. If it's an 8-digit coordinate, you want to split it into 4 and 4. Sometimes you get 6 digits, sometimes it'll be 10 digits. Always just split them in half. The first two groups, the parts that contains a letter, tells you the zone of your coordinates. We'll only look at zones for now. This is what zones look like. Okay, this is how MGRS system divide up practically the world into different zones. See Los Angeles right here? That's 11S. If you zoom in on 11S, you get more zones. You can still find Los Angeles right about here. Right, as well as San Bernardino, we're all in empty zone. So the first two groups with letters tells you the zone that you're in. If you zoom in on empty zone, if you can't see the highlighted green portion, that's the kind of the boundary of this zone. If you zoom in on empty zone, there are no more letters after that. Right? Going back to our coordinates, first two groups tells you the zone you're in, and then it comes down to the two groups of numbers. The first group tells you the left to right position of your coordinates. The second group tells you the up and down position. Going back to the same map, we're in the empty zone. As you can see, the numbers labeled at the very bottom. Okay? This doesn't mean that only this portion is 0 or 1 or 2. This number means this entire line is 0. This entire line is 1. Okay? Within empty grid, just think about it as a decimal system. We're using 10 lines from 0 all the way to 9, okay? Dividing up empty zone into 10 sections, left to right. Zooming in on it a little bit more, let me go back. So let's say everyone can see the red crosshair in the center, right? If this is 5 and this is 6, what do you think the left and right coordinates, left and right numbers should be for the crosshair? You're right in between 5 and 6. Think about the crosshair splitting right in between.
Would it be 5006?
It'll be 5.5. 5, 6, right in between 5.5. look at between 7 and 8, go all the way up, you kind of see where San Bernardino is. We can zoom in on San Bernardino. Right, see between 7 and 8, that crosshair is roughly the location of our campus. Okay. If this is 7, this is 8. Is that crosshair right on line 7? No. Okay. Has it got to 7.1? Not really. Okay. So the left and right coordinates of that red marker is in between 7.0 and 7.1. And zoom in on that crosshair, you see 7.0, 7.71. Right? As you can see, we went from 1-digit lines to 2-digit lines. Why is that? We're simply dividing up 7 and 8 into 10 more sections. Think about it as decimal places. 7, 7.1, 7.2, all the way 7.9 to 8. Now we erase that decimal, you get 70, 71, 72, all the way on and forward to 8 and 9. Make sense? Any questions so far? Cool. So that's where our campus is. This is about roughly, actually this is exactly how zoomed in these maps will be when we're talking about maps that's meant for ground operation, right? They will always be zoomed in enough where they have 2 digits for each grid line. Right? This is called the grid line. This is called a grid square. So for your reference, this is roughly, no, this is exactly 1 kilometer wide. Okay, between each 2-digit numbers, they're 1 kilometer. Now if we focus on our campus, that is the location, that is the building that we're in right now, SV building, right, where the red mark is. Now, if this is 7.0, this is 7.1, let's guesstimate the left and right position of that red mark, okay? Right in between, this will be what? 70.5. Split that in half, 70.25. Still getting not quite there yet. Split that in half, 70.125. Split it one more time. That's 70.06. Right? 70.06. Now, if we once again erase that decimal places, what do we get? 7006. Right, now add in the letters we got from earlier. Right, remember 11S, MT, 7006. That's the first half of our coordinates for this building that we're in right now. Okay. Now let's introduce the same concept, but for up and down position. If this is 82, and all the way up there, that's 83. Is the crosshair right in between those two, splitting evenly? No. Is it quite at? So it's past 82.5. Right? Is it quite at 82.6? So it's in between 82.5 and 82.6. What would that be? 82.55. There you go. Erase the decimal, you get the last 4 digit of that coordinate. Okay, that is the logic, the concept behind MGRS system. Just for your reference, if you are to write that out in a longitude, latitude traditional system, to get a rough accuracy, that's how long the coordinates will be. It doesn't seem that different, but think about when you're writing down these coordinates or thinking about these coordinates, you know that you're not getting out of this grid square. So the first few letters, while you're still going to use them when you call out coordinates, but they're pretty much going to be the same. You're not walking out of this grid zone. So you really just have to look at that part. Does that make sense?
Sure.
Any questions so far? Yes.
The questions off the beginning. So for your coordinates at the end, I know you mentioned to split it in half, right? And that would be the left and right is the
matter how many numbers. The number of digits that you'll get will always be an even number. Does that make sense? Either be 6 digits, 8 digits, 10 is about as far as you go. That narrows you down to 1 meter squared. Just simple math. Now, the method we used pretty much is guesstimating, right? Looking at these things on paper, they're kind of small, hard to tell. And the tool we use to help us measure on a real physical map is what we call a protractor. It's nothing special about it. It's just think about it as a rule that we use to read maps. They are, you see different size triangles. Each triangle will match per 1 grid square, depending how the map was printed. It's a bigger map, zoomed in more, that grid square will be bigger. If it's zoomed out a little bit, it's using the same reference lines, but those squares will be smaller. You match the correct size triangle on top of the grid square. For example, a little hard to understand, but the yellow lines makes a 1 grid square. Okay? Using this protractor, you're simply measuring what is the distance from this side to this side. That's 5. Okay? What is this line? It's 11, right there. Right? These numbers they can be written anywhere on this line. As long as it fits, sometimes it's just for convenience sake they can put as many lines as they want to, but that 11 is this line. This is 12. This is splitting right in between. What would that be? 11 half. Now you raise that decimal, it would be 11.5. That's the left to right coordinate. From up and down, what is this line? Actually, no, this is the grid line. What is this? Take a wild guess. Not that many numbers on the screen. 81. This is 81. That is 82. Think about decimal places. 81.1, 0.2, 0.3. Right? 813. Now you combine it to 115,813. That make sense? Right. The way I think about it is just always count right and up. Go right, find your coordinate, go up. That concludes my brief for the most part. No, I went over what is it, military grid system. We broke down some coordinates, saw some examples, and then talked about protractors. We'll have some questions, but we'll be using this a lot for next week's mission scenarios, so study them.